All right, so we are going to learn the chord properties of a circle. Do you remember the definition of a chord?
Yeah, it's like
a line that goes from any 2 points that doesn't go through the center.
It could go through the center.
So that would be a diameter.
A special type of chord is a diameter. But yes, any line that goes from one edge of the circle to another edge of the circle is a chord. And for any chord, if you draw a radius, okay, that cuts this in half. So if you draw a radius that cuts a chord in half, that will always be 90 degrees. So if you know that the angle between a radius and a chord is 90 degrees, then you know that it cuts it in half. And if you know that it cuts it in half, then you know that all of those angles are all 90 degrees. And right, when we draw the little square for an angle, that means a right angle, 90 degrees. Now, this doesn't happen, like I can draw a radius here, right? That didn't cut that chord in half, did it?
no.
So these angles aren't 90 degrees. But if I draw a chord here, and I draw a radius that makes 90 degrees through that chord, then this side and this side are going to be the same. And all of these will be 90. I can go back for you. Got an extra? Thank you.
Joe, can you stop pushing my chair? Hey, Joe. I hope you die. Just kidding.
Ready, Abe? So, if you wanted to find the center of a circle, what you could do is you could take any chord here, cut it in half, measure 90 degrees, and draw a straight line. Then if you took another chord somewhere else, cut it in half perfectly, measured 90 degrees. So these are cut in half perfectly. These ones were cut in half perfectly. You measured 90 degrees. I don't know how good my drawing is. But if you did that, where those two lines intersect will be perfectly in the center of your circle.
Wait, what's the date today?
The 31st.
31st.
Tomorrow's the 31st.
31st.
Today is the 30th.
Oh, yeah.
Okay? So if you wanted to find a center of a circle, you could do it that way. So what's going to happen is you're going to get questions that use this property. So here's a circle, and they're telling us from C to D is 24, and from O to M is 5. So I can put a 5 right there. And they also show us that there's a 90-degree angle between OM and CD. So the property that you have to be able to recognize is whenever you have a radius or a diameter going through a chord, you have to either look for, is the angle 90 degrees? Because if the angle is 90 degrees, What do we know about these two sections? They're the same. They're the same length. We also have to look for, in some questions, they'll tell us that two sections are the same length, and then you can go and label 90 degrees in all four of these angles. Now, if they're the same length, how far is it from C to M? 12. And 12 from M to D. Because they told us in the question that all the way from C to D was 24. So now we still need to find out how long the diameter is. Is there a diameter drawn in this picture? No. We've got a chord, and that chord isn't a diameter. We want to find out how long the diameter is. Can you see that the diameter is going to be longer than 24?
Yes.
Because the chord is already 24, and our diameter is going to be longer. So we're going to need to be strategic, because we're going to have to draw a line on this picture to help us find the diameter. That line that we draw is either going to be a diameter or it's going to be a radius. Because if we find the radius, we could just double it to find the diameter. So now we'll look at this picture, and we have to be strategic. Can you see where we could draw a radius or a diameter that we could use the information that we have to help us solve?
Well, the radius is 10, or that radius is 0.2.
We know, okay, this is a good point here. We know from here to here is 5, so the question is from here to here also 5? And the answer is no.
It's not the same thing.
It's not going to be the same. The chord property says that if you have a radius at 90 degrees with a chord, the chord gets cut in half. But the radius doesn't have to get cut in half.
So the 5 isn't the radius, because it's not.
The 5 is only from here to there. And the 12 is from here to here.
Also, because the 90 degrees cut the chord.
The 90 degrees cuts the chord in half. And that only works if the 90 degrees is a radius or a diameter. If I draw a 90 degree over here but doesn't go through the center, then it doesn't cut it in half.
It cuts uneven.
I still need to find the diameter. So you're going to have to either draw a radius or a diameter somewhere on this diagram that we can use the information we have to figure it out. So I'm going to draw a radius that I know you can't figure out. There. If I draw that radius, could you figure out how long that is? No, because it's not part of anything. Oh, that's a good idea. Now, perfect. And what I tried to show you is a mathematical strategy that often works. If you can't figure out what to do, try something that for sure won't work. And as soon as I drew something that didn't work, you guys came up with, oh, draw it from O to D. And what does that, you see with the red, the green, and the black line, that makes a right angle triangle? It could have been C to O as well, yeah. So I got that red line there, I've got the green line over here, and then we've got the black line there. And what do we know? The red line is how long? 5. The green line is 12. And we know that this is 90 degrees. So it's a right angle, so 5 squared plus 12 squared equals C squared.
25 plus 124.
And then you have to take the square root of both sides Go to your calculator. And it's 13. So if we label that on our diagram, we know that from O to D is 13. What was the question asking us to find? So the diameter is 26. Because the diameter is all the way across, and that 13 is just the radius.
So will we do like ovals, or is that for like triangles?
Well, isn't that, that's not
No, we just do circles.
Just circles?
Yeah.
It's like an oval.
Yeah, it does actually look like an oval to me.
It's longer.
Yeah.
It's definitely taller
Right?
than it is wide.
So you're trying to play us, Mr. Junior. I'll make sure I won't.
All right. The diameter of this circle is 20 centimeters, and the distance from chord AB to the center of the circle is 8 centimeters. And on the diagram, they've got a little 90-degree measured there. Okay? So, from our chord property, since this line is at 90 degrees, if you extended it, you would make a radius. What does that do to this chord AB?
Cut in half.
Cuts it in half. So we know this side and this side have to be the same.
Yes, sir.
We also know from the question that the diameter is 20 centimeters. So what does that tell us?
Well, O to B should be 10, right? Or O to A.
Yes. Okay, so this is, if we draw this special line here again, we want to make right angle triangles, or this one, O to B. These are going to be 10 because all the radiuses in this question have to be 10 centimeters. And the 8 is right there. So do you see the right angle triangle? And sometimes it's nice just to draw it. You see the right angle triangle right here with A,
Wait, how did we
center O? This is 8 and this is 10.
how did we make sure that the triangle's outer angles were half the is it just because they come from one side? Oh, okay, never mind. Just because it goes to the center. Makes sense now.
Okay, good. So can you see that you made a right angle triangle?
Yes.
And you don't know this side right here. When I set up Pythagorean, where will I put things? A squared plus B squared equals C squared. What don't we know?
A squared or B squared?
We don't know A squared or B squared. It doesn't matter which one you choose.
I'll just say A.
A squared plus B squared equals C squared. A squared.
64 and 100. 164 and then
Here we're going to have to subtract 64 on both sides. They're not on the same side. Then we can put those like terms together. Square root both sides. And we get this as 6.
Education and math is my game.
So what was the question asking us to find? The length of chord AB? So, what is the length of chord AB? 12 centimeters. Because this will also be 6 there. So because those two are the same, you know the length of chord AB is 12.
Wait, is oxidant like clear?
Okay?
Yeah, I know, but Joe always has water.
Move out of the way.
It'd be like have to be nice to him.
Okay. So now that we've done a couple, I'm going to get you to try to figure this one out on your own.
Easy. Easy peasy.
A couple of things that I noticed from some of you, you guys are getting really good at seeing that drawing a new radius in that makes a right angle triangle is going to be very helpful. Now, in that right angle triangle, first of all, also since this is 90 degrees, we know this and this are going to be equal from our chord properties. In this right angle triangle, we know this is 14, we know this is 90 degrees, but we don't know the other sides yet.
No, I still go to church. No, I stopped like. Oh, I want to go somewhere.
From here to here, from here to here is 14 as well.
Yeah, it's right there.
Yeah, it's like the front of the
It's
school.
like right.
It's like on the right of the school.
Why is O to B 14?
So the church is right over here.
Is that an all girl?
They want to talk about church.
Why is O to B
Boy.
14?
Because it's half a radius.
Because it's also a radius. Now, if this little section right here is 2, you subtract 2 from 14, and you'll get this section here is 12. You can now do a squared plus b squared equals c squared.
No, Joe. Joe, want to go to church with me? No, why not? Let's go. I come on my same church. Yeah.
Put our like terms together.
I've never been to church in my life. I just want to go. I haven't someone say, no, let's go.
Square root both sides.
I've been to church. Oh, I've been to church twice. Once for a wedding, once for. Everyone goes to church on a wedding. I've never been to a wedding.
So this part right here,
Wait, let's share where's the toaster come from?
because if we go, the whole green line is 14.
Yeah.
The little red line here was given to us to be 2. 14 minus 2, which I know I should have taught you earlier, is 12.
Why don't you want to go?
Said I.
What do I do? Christian or Catholic. But why did you go to church with your grandma? I'm not Christian either.
What's the length of chord
Let's eat the pig.
AC?
Let's get baptized. So I can go to church.
Show you two huge guys getting baptized at Joe.
So, in the last 3 examples, we've seen the following strategy happen over and over and over again. We need to draw a radius to make a right-angled triangle.
No, it's the girl from the garage.
In this one, if we draw from O to A, that makes a radius. And since we're already given that this is a right angle here, we have a right angle here, 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 and here, all the way around. And in that right angle triangle, we know one side is 2, the other side is 4. We can now do a squared plus b squared equals c squared. So 2 squared plus 4 squared equals c squared. 4 plus 16 equals c squared.
I'm guessing 4.5.
20 is equal to c squared.
You're not guessing, you should do it.
And now we can square root both sides, and you get 4.47. So if you round it, you'll get 4.5.
Yo, you're so good at guessing.
Now, what's special about this 4.5?
Oh my gosh, it touches the circle in the middle.
That's a radius.
Oh my gosh, it's a radius.
And we need to find the area of the circle, and the area of the circle is pi r squared. So area equals pi, the radius, which is 4.5 squared. Now,
63 point.
if you have a calculator, sometimes when you're doing a calculator, I'm going to show you on this calculator, if you round things early, your final answer might be off a little bit. So I'm going to show you that if you take pi times 4.5 squared, you get an answer of 63.6. But if you had done on your calculator the square root of 20, because that's where we got our 4.5 from, and you went to type in pi times 4.5 squared, but this time I'm going to go pi, and a lot of times on a calculator, they'll let you take the answer that you had before instead of rewriting it. So I could write 4.47. On my calculator, right here, I've got an answer button, which lets me steal this answer. And if I do that squared, notice my answer is a little bit different, 62.8 as opposed to 63.6. So by rounding early, we get 63.6. The actual answer, if we don't round early, is 62.8. This is an area question, so we have to write centimeters squared. So, to start off with, okay, Maddie, you want to just turn around? Caden, thank you.
Step by step, like by row.
I have the right to laugh with you.
Hey, what's the first step?
All right. In this question, the first thing you're going to do, we want to find B to C. If we look at the diagram, what do we know from our theorems? We see that we have a radius cutting a chord in half. That means all of these are right angles.
I knew it. Gotcha.
And because of that, you've got a triangle, a right angle triangle with this side is 6, this side is 8. You can do a squared plus b squared equals c squared.
6 and that would equal 100 and you would 10.
Square root both sides. So we found out that our radius is 10. That means this is also 10 over here. From our theorems from yesterday, or the other day, there's an inscribed angle that you know the angle of. This inscribed angle right here is an inscribed angle off of a diameter.
Oh, I see.
What is the angle of an inscribed angle off of a diameter?
9.
That's 90 right here.
Noise.
What else do we know since these two sides are the same? This side is also 8. Now to find B to C, there's two methods you could use to find B to C. The way that you would most likely use method 1 is you would see this big right angle triangle here in red. Can you see that big right angle triangle in red? The only side you don't know is from B to C. I'm going to call that a squared. A squared plus 16 squared equals 20 squared. Subtract 256 on both sides. Square root both sides. And you get A is equal to 12. I can go back up.
Unoriginal, Joe. Unoriginal.
But yeah, those are for his cards.
Jacob goes.
So a second method uses the
I
fact
see it now.
that this green triangle
I said that right here.
has this angle, the red triangle has this angle. That means that this angle in the red triangle is equal to this angle in the green triangle. And what do we call triangles that have all the same angles? Well, what do we call a pair of triangles? A pair of triangles like the red triangle and the green triangle have all the same corresponding angles. What are those two kind of triangles called? They're called similar triangles. So the green triangle was similar to the red triangle.
Copy that.
In the green triangle, we have 6, 8, and 10. In the red triangle, we had 16 and 20. What do you notice? How much bigger? Times 2.
It's gonna be 12.
So it's going to be 12. And that's the same as we got here. It all depends what you see. If you can see the similar triangles, you can use that technique from earlier. If not, you can always use a squared plus b squared equals c squared.